Okay, so at this point we've covered complex number, addition, subtraction, and multiplication. Next up should be division, right? Not quite. There's a secret operation on this list called conjugation. This one's pretty easy, but we need to understand it because it's used in division. So the conjugate of the complex number a plus bi is denoted by a plus bi with a bar on top. It's equal to a minus bi. For example, the conjugate of 2 plus 5i is 2 minus 5i. We just flip the sign of the I part. And the conjugate of negative 3 minus 4i, well, we only flip the sign of the I part, the imaginary part. So it's negative 3 plus 4i. Makes sense? What about the conjugate of negative 7i? Well, we can rewrite negative 7i as 0 minus 7i. And then it's clear the conjugate is 0 plus 7i, or just 7i. Well, what about the conjugate of the real number 3? Well, 3 is 3 plus 0i, so the conjugate will be 3 minus 0i, which is still 3. So if it's a real number, the conjugate does nothing. If it's purely imaginary, it flips the sign. And if it's a combination of both, you just flip the sign of the imaginary part and leave the sign of the real part the same. Let's do a few more examples. Negative 7 minus 2i. So we keep the negative 7 the same and flip the imaginary part. Negative 7 plus 2i. Conjugate of negative 4. There's no I, so it's just negative 4. Conjugate of 2i. Well, here there is an I, so we flip the sign to negative 2i. Makes sense? Well, here's the cool thing about complex conjugates. Whenever you multiply a complex number by its conjugate, you get a non-negative real number. Let me show you. Let's say we take 2 minus 5i, and we multiply by its complex conjugate, which we know is 2 plus 5i. We just flip the sign of the imaginary part. Well, when we FOIL this, the first terms, 2 times 2 is 4. The outer terms are 2 times 5i is 10i. The inner terms are negative 5i times 2 is negative 10i. And the last terms are negative 5i times positive 5i is negative 25i squared. Now the outer and the inners cancel out. We have 10i minus 10i. That's just 0. And the I squared is negative 1. So this negative 25i squared flips the sign to become positive 25. So we end up getting a positive number plus another positive number, which simplifies to 29. Something like this will always happen. So whenever you multiply the complex number a plus bi times its conjugate a minus bi, you'll always get a squared plus b squared. Right? In this case, a was 2, b was negative 5. So if we do 2 squared plus negative 5 squared, we get positive 29. Pretty cool, huh? Let's talk about complex division. Let's say, for example, we have 2 minus 3i over 1 minus 7i. How can we simplify this and write it in the form a plus bi? Well, the thing to do is you look at the denominator, the thing on the bottom, and you multiply by the complex conjugate over itself. So the complex conjugate of 1 minus 7i is 1 plus 7i. So you multiply by 1 plus 7i over itself. Why? Well, we know when we do this foiling on the bottom, we're just going to get a squared plus b squared, which is a positive real number. And then we can FOIL on the top and simplify. And this will allow us to write everything in a plus bi form. Let me show you. On the bottom, if we FOIL this out, I'll just do it for once. So first times first, 1 times 1 is 1. Outer terms, 1 times 7i is 7i. Inner terms, negative 7i times 1 is negative 7i. And last terms, negative 7i times positive 7i, negative 49i squared. So we see that these will cancel. This negative 49i squared is actually positive 49, and 1 plus 49 is 50. So the denominator ends up being 50. We could have skipped a lot of these steps and just did 1 squared plus negative 7 squared. So 1 plus 49 is 50. Now, on the top, we can FOIL again. 2 minus 3i times 1 plus 7i. So the first terms, 2 times 1 is 2. Outer terms, 2 times 7i is 14i. Inner terms, negative 3i times 1, negative 3i. And last terms, negative 3i times positive 7i, negative 21i squared. Okay, we can combine like terms. 14i minus 3i is 11i. Negative 21i squared, well, that's positive 21, because we know I squared is negative 1, which flips the sign. And 2 plus positive 21 is positive 23. So our final answer is 23 plus 11i over 50. And you can also write that in a plus bi form as 23 over 50 plus 11 over 50i. Any questions? Let's do one more final complex number division. 1 minus 4i over 2 plus 3i. So as usual, look at the denominator and multiply by the complex conjugate over itself. So the complex conjugate of 2 plus 3i is 2 minus 3i. We flip the sign of the imaginary part. And we multiply by this over itself. Because anything over itself is 1. So we're multiplying by 1, we're not changing the value. All right, so the denominator, I'm going to skip the FOILing here, because we know it's always going to simplify to a squared plus b squared. It'll be 2 squared plus 3 squared. And that'll be 9 plus 4, which is lucky number 13. Okay, FOILing on top. First, outer, inner, last. So first, 1 times 2 is 2. Outer, 1 times negative 3i is negative 3i. Inner, negative 4i times 2 is negative 8i. And last, negative 4 times negative 3i is positive 12i squared. So to combine like terms, the outer and the inner, that's negative 11i. This positive 12i squared is really negative 12 because I squared is negative 1. So 2 minus 12 is negative 10. And we get negative 10 minus 11i over positive 13, aka negative 10 thirteenths minus 11 thirteenths I. All right, thanks for watching. Don't forget to share, like, and subscribe. Also, comment.